Exact multicollinearity means that one regressor is an exact linear combination of others, including an intercept, a male indicator, and its female complement is one example, including two components and their exact total is another. The regressor cross-product matrix is then singular. So the normal equations do not have a unique coefficient solution. The separate effects cannot be recovered from that parameterization. Software commonly responds by dropping a perfectly collinear column. This is a computational necessity, not a scientific decision about which variable belongs in the model. The researcher must identify the redundant representation and choose a parameterization that preserves the economic question. Otherwise, the reported reference category or coefficient interpretation may change without being noticed. Approximate multicollinearity is less obvious. The regressor matrix remains invertible, but one or more eigenvalues are very small. OLS exists, yet the inverse magnifies sampling noise in the weakly identified directions. Small changes to observations or specification can then produce large coefficient movements or sign reversals. Under homoskedasticity, the covariance matrix of beta hat equals sigma squared times the inverse of x transpose x. Highly correlated regressors make relevant diagonal elements of that inverse large. Standard errors rise because the data do not clearly distinguish the separate all-else-equal effects of variables that move together. A characteristic pattern is a high R squared and a significant overall F test alongside weak individual T statistics. The regressors may collectively explain why, while their individual contributions remain hard to separate. This pattern can suggest multicollinearity, but it is not sufficient by itself because weak T statistics have many other causes. For two standardized regressors, the variance inflation for one coefficient is related to 1 divided by 1 minus the squared correlation between them. As the absolute correlation approaches 1, the denominator approaches 0 and the coefficient variance grows rapidly. With many regressors, small eigenvalues generalize this same geometric idea. A correlation matrix is a useful first screen. Large pairwise correlations reveal obvious overlap between two regressors. Its limitation is equally important. A variable can be nearly explained by a combination of 3 or more variables, even when no pairwise correlation appears extreme. Pairwise inspection is therefore a beginning, not a complete diagnosis. The variance inflation factor examines each regressor against all the others. Regress xj on the remaining regressors and record r squared from that auxiliary regression. The variance inflation factor equals 1 divided by the quantity 1 minus that r squared. A value of 1 means no linear predictability from the other regressors. Large variance inflation factors signal that an individual coefficient is being estimated from little independent variation. Thresholds, such as 5 or 10, are only rough conventions. The consequences depend on sample size, measurement quality, the coefficient combination of interest, and whether the goal is structural interpretation or prediction.